Okay, last lesson we talked a lot about the shape of data, the type of data, how data can be things like integers or varchars or whatever. And we've come across that before when we created databases. Now what we need to look at is the relationship between individual data items. And we do that, there's a number of different ways to do it. I actually had to learn a language called Z at university, which is a calculus-like language that describes databases, and we all thought this is ridiculous. But once it clicked and you realize, oh, that's actually really easy, it became quite convenient and quite quick to use. But I think entity role diagrams are by far the easiest way to look at the relationship between different points of data. Now, I've got it up on the screen. I'm quite happy for you to watch, but it will be of benefit if you take a few notes yourself. So either on a piece of paper or on your computer. I'll be drawing circles and boxes and things. You can use the drawing tools if you want to be really neat, but I'm not going to be neat. If you're able to draw on your screen in some way, then you can try and take these notes the same way. If not, grab a piece of paper, there's some in the top drawer there, and we're away. I'm recording, so I can't. Okay, while you're doing that, I'll set some things up on the screen. Yep. Okay guys, take a seat, he'll bring it back. Okay, I've put up a couple of different statements. How many, well, I've just told you, I shouldn't have said that. I put up facts, okay? The facts are that little Johnny likes swimming, he also likes basketball. Now, you'd recognize that as plain English, yeah? But what we're going to do is we're going to reduce that down to entities and roles. Entities and roles. And so, the first thing I'd like you to do is identify an entity from those statements. Entity. I knew it was going to do this for me. Johnny, is it tab, is it?
Yeah. I think so.
Ah, yes. Are there any other entities in those statements?
No.
There are not any other entities in those statements, am I right? The word swimming is not an entity, is it? Nor is, well, basketball could be called an entity, or the game could be an entity, which leads us to how can we derive other entities from those statements? Sorry? No, we've already identified Johnny, that's one entity. I'm asserting that there's a second entity, but it's an implied entity. It's not stated outright. What are swimming and basketball together? What might you call those? Sports or activities or hobbies. Okay. Let's leave it as hobbies because he might also like crochet, and that's not a sport. Okay. So let's go hobbies. Now that's an implied entity, am I right? What I'm going to do now is I'm going to generalize those two entities. Okay, I'm talking about heading towards making a database. Yeah? So if I'm heading towards making a database, is this database going to be about Johnny, do you think? Or is it more likely to be about people and their hobbies? Okay, so let's generalize. Instead of Johnny now as the entity, let's call it person or people to be consistent. So now we're talking about people and hobbies, are we not? Right, let's move away from that for a little bit and look at the verbs. Okay, from the two statements right at the top now, they are facts. From those two statements, what are the verbs? Just realised this is very small. I should probably do it this big for you. Well, swimming is a verb, isn't it? But in this context, we're actually using it more like a noun, more like a hobby. What's the other verb? What's Johnny doing to these hobbies? He's liking them. Correct. Bet you didn't think you were coming to Digital Solutions today to get an English lesson. Basketball. Maybe that's something to do with basket weaving. There we go. All right, now when we are looking at facts from a digital point of view, we're looking at putting these things into a database. What we need to do is make a concise, simple sentence, what we used to call deep meaning elementary sentence. I'll talk about that later. Related to these entities and verbs. That's what we're after. And we're looking at the generalized version of these entities. Okay? So I'm going to now come down here separate to all of that, and I'm going to write a generalized version of that. Instead of the plurals, I'm going to use the singulars. I'm going to say person likes hobby. That is a simple, distinct, atomic fact. What do I mean by atomic? At a basic level, right down at the bottom level. I can't break that up into anything and have some meaning. Person is just a data point. Hobby is just a data point. We're interested in relating data points together to make a database. So, person likes hobby is our first fact. Now, when we're drawing entity role diagrams, what we do is we draw a circle for an entity. Black, yes, I like black. Thank you. We draw a circle for an entity, and we do a little stem off that circle and put a box on it for the role. Now I'm going to write inside that circle person. Should have typed it, would have been better. And I can't fit it inside the box, but I'm going to do a little call out like that and go likes. Now we have a second entity involved in this, so I'm going to, out the side here, draw a circle with a stem and a little box. And in that I'm going to put hobby, if I can fit it. Really should have typed it, look at that. Now that role there also has a name, and that name is simply is liked by. Now from now on, I'm not going to do the two roles, I'll just do the main role. Okay? So you can see we can read this sentence both ways, can't we? We can say a person likes a hobby is liked by a person. Easy? That's a relationship. Now in our diagrams, we don't need to really label the second relationship. We're only interested in the first one. So that's all entity role diagrams are about. Step one.
So, taking information, dumbing it down pretty much.
Dumbing it down, breaking it down into atomic statements.
And then drawing like that basic.
And then drawing them as a bubble diagram. Yep.
Okay.
And you can think of these things as spheres, although we draw them on paper, so they're two-dimensional. But you know, they could be just connecting out in space. And I like to think of it as spheres floating through space like an atom, with something that's wanting to be connected to something. That box out the side is like a socket looking for a plug. Okay, and one entity then can plug into the other entity, or little magnets that are attracting each other and connecting these things together. Always helps if you've got a bit of a story. Okay, that's step one. And under the old system, that used to take us a week to teach you. Yeah, there's a whole lot more technical stuff in the background I'm leaving out. Okay, from here, what we do is we actually provide that. Remember I said it was called a deep meaning elementary sentence? That's an elementary sentence. To provide deep meaning, what we need to do is put a unique identifier on everything. A unique identifier on everything. And so we're looking at that sentence now, and we're looking for a unique identifier. What do you think a unique identifier for a person is? So their name. So the statement at the top says Johnny likes swimming. So quite valid to say the person is Johnny. Am I right? Do we have a problem with that though? Oscar does. There could be more than one Johnny. So it can't be a unique identifier if it's identifying more than one person. So why don't we use a number? And that's where we get ID numbers in databases from. We have to have something that uniquely identifies everybody in the database. You know that your student number on TASWeb is what I'm using in my systems all the time. Okay? So that's your unique identifier. That's why everybody has a driver's license number. That's why you got a bank account number. Yeah. They're infinite. They're easy to assign. Computer will do it automatically. You got your license? Oh, good. All right, so how do we deal with that? Nice and easy. I'm going to write that sentence again. This person likes hobby. Now I need to look for a unique identifier for the two entities. We've just said that we're going to use an ID number, so I'm just going to put in brackets after it ID. And then in hobby, what do you think we could use for a hobby? What's a unique identifier for a hobby?
Isn't a hobby just unique?
The name of the hobby is the unique identifier. Basketball doesn't have to be like uniquely identified in any other way. Basketball is basketball. Several people can like that, and that's what we're going to look at as our very next thing.
People at work, there's like different versions of basketball.
Then they'd have different names.
Like 30
Handball.
This is a 5v5 encore.
Yep. Handball. European handball.
Yeah.
Chinese basketball. Okay, so they've got different names. A more descriptive name. Once you see how all of this stuff fits together for an entire database, you'll realise that it's perfectly fine just to use a piece of text for hobby. Because there's going to be many people that like basketball or European handball. So I'm just going to put after it, name, done. Now I'm not going to redraw the whole diagram. I'm going to add to the diagram, but I'll do it in blue. So what we do is underneath the person, we simply add what's in brackets. Underneath the hobby, we add name inside the circle. I'm regretting my decision to use the pen now. It looks terrible. But I think you get the general idea. Right, the third thing we're going to look at is what we call, and that would have taken another week to deal with, talking about complex identifiers and all that sort of nonsense. We'll come across that as we start to build our database. We'll talk about that. Okay, next thing we're going to deal with is uniqueness. Uniqueness constraints. There are three. There is a one-to-one constraint. There is a one-to-many constraint. And there's a many-to-many constraint.
This is like when you drew all the databases up and
Exactly. Now, what this means is this entity can play this role once. This role can be played by just one entity. That's the one-to-one constraint. I'll talk about examples of that in a moment. A one-to-many, which is probably going to be the bulk of what we look at, is going to be the entity can play this role once, but that role can be played by many entities. All right, come back to that in the example. And many-to-many means many entities can play the role, and that role can be played by many entities. So the 1 and the M, or the 1 and the 1, the M and the M, belong to the boxes in the middle. It's all about the roles. Let's see if we can figure out which of those three person and hobby is. Can a person have more than one hobby?
Yes.
Absolutely. Can that hobby be played by, or can be the favourite hobby of many people?
Yes.
Yes. So it's clearly a many-to-many relationship. When it's a many-to-many relationship, what we do in red is we look at the roles and we say that's a many-to-many relationship. Now that stroke that I just put on there, that line, is actually the number 1. It's a uniqueness constraint. So we're describing the uniqueness of this relationship. What that means is only when those two things get together can we provide uniqueness. Only when those two things are actually put together do we have a unique thing. Okay? Let's have a look at the other two. One-to-one relationship. Can you think of something that is a one-to-one relationship? Say again?
Eat something, so no one else going to eat that.
No one else is going to eat that. I like that. But multiple people could eat the same thing, like the same type of thing. So if we're putting that in a database, it would be you as the entity and a vanilla slice, which is one of my favourites. But I could also buy a vanilla slice. Yeah, so that's a many-to-many as well.
What about your ID number?
Bingo. You and your ID number is a uniqueness. Yeah. You can only have one ID number. That ID number can be only for you. That's a one-to-one. Now you, we're describing as you. We've already said ID numbers. A car and a registration plate. So the car might be identified by its VIN number, and the registration plate has to be unique. Can't have two registration plates the same.
Email on a person?
A person and their personal email could be, yes. We do have group emails and things like that, but if you ignore those, a person and their email, which is often why we use an email address as the ID for the person on a website, for instance.
Does some use username? Some websites use usernames. Yeah, but can you use the same username as someone else? Sometimes on certain things you can, but sometimes
Because you have an ID or a tag.
yeah. Well, I think you sign in like with your. Oh no, you have a username, but you just change your display username. Yeah. So you can have the same display username.
What a lot of websites do is they do enforce unique usernames, but they also still have an ID number behind it. I made the decision on that thing I wrote just recently that I was going to use the staff's login name, so Stephen.Blair, as the username everywhere. It's kind of a little awkward because it's a piece of text. It is always better to give them a unique number, and then you can deal with that number across multiple things. STEPHEN dot BLAIR, so I've got 13 letters in there. That's 13 bytes of information I'm actually storing as my unique identifier, and I'm storing that in the staff table, and I'm storing it in the teachers table. So those things are considerations on really large databases, storage space. Whereas if I gave everybody an integer, I can store 1 byte would allow me 255 characters or 255 users. 2 bytes gives me up to goodness knows what. I've forgotten my binary numbers.
Like 1 byte is
2 to the power of 16.
1 byte is like 255 users.
Yep. Whereas my 13 bytes, 2 to the power of 13, if I use numbers, that's the size of the number it could use, potentially.
So that's like why people are crazy over like 12 gigabytes back in the day.
12 gigabytes. When I started out, our computers had 640 kilobytes of RAM.
I'm dead, so.
because Bill Gates came out saying we'll never need anything bigger than 640 kilobytes, so the chip manufacturers designed around that. When we went to 1 meg of RAM, we had to upload it was called, is it highram.exe or highmem.exe, which was a memory extension program that tricked the processor into addressing that extra bit of RAM above 640. Then once we started doing that, the chip manufacturers went back to the drawing board and redesigned the chips so they were open and we could actually just expand them in future designs. But yeah, because Mr. Gates stood up and said, one guy stood up famously right back in the beginning of computing, when computers were entire rooms or entire floors of buildings, said he thought there would be use for maybe 5 computers on the planet for the rest of time. That guy was the CEO of IBM. It was in his best interest to actually sell computers. He said, I can only see the use of 5 of these worldwide.
There's more than 5 computers in here.
There's more than 5 computers. It's more than 5 computers on my desk. Oh no, there's not. There's only 4. I got one around the corner. There you go. Yep. Well, no, 2 of those computers should be in your lockers, but yeah. Okay, so uniqueness constraints are all about the number of times that role can be played. So a person can have many hobbies. A hobby can be the hobby of many people's. One-to-one means it's a uniqueness thing. So you and your ID, or the car and its registration plate. One-to-many is an interesting one. Your address. Unless you are living alone as a 16-year-old, your address is a one-to-many relationship. Yeah, that one address, many people. That person has one address. Okay, that's a one-to-many. Say again? Password is a good example, actually, because you've got no idea what other people type. Yeah, somebody can have exactly the same password. So for you, you have one password, but that password potentially could be the password for many different people. Absolutely. Yeah, it's a good example. And when we think of our examples, think of things we might store in databases. Okay, the car was a good example of that. Obviously, we need a registration database. Okay, we've talked about that. Let's talk about the other 2 relationships. Is what?
Is a VIN number personalized to just the car?
That individual car, yes. Every VIN, vehicle identification number, is unique worldwide. Like a MAC address on your computer. It's unique worldwide. Okay, I'll keep these in red actually, because I've done the one up the top in red, and that'll help you identify when you look back on these notes. One-to-one relationships. Now, remember I said we won't worry about the entities. Remember I said that the little line I put there is actually the number 1. It's uniqueness. So a one-to-one relationship, both of these boxes will be unique. A one-to-many, oops, how did I get to the rubber? A one-to-many relationship, the one will go over the unique part. So I said one-to-many, so that means 1 is on the left-hand side. And of course, we've already seen the example of many-to-many, so I'll just put it up. The combination of these roles is unique. That'll become clearer a little later on. Now, I should point out that one-to-many, of course, can be many-to-one. We're not remotely interested in the position of the circles or the boxes. So that is the same thing as one-to-many, even though it's a many-to-one relationship. You can just flip them over, no problem at all. Later on, we'll be drawing them like spokes on a wheel.
Oh, so it doesn't matter which way the one-to-many goes?
Doesn't. In fact, it doesn't matter which way any of them go. Think about it. The other 2 are perfectly symmetrical. All right, I'm going to end this recording here because, as I mentioned, I may run out of memory doing this, run out of disk space. So I'm going to end the recording here, and then I'm going to restart if I've got enough room, and we'll put that, we'll move on from this point. But that's a good little chunk.